In this video on factorizing algebraic expressions, we're going to have a look at the sum and difference between cubes. Earlier in this chapter, we had a look at products and we multiplied a binomial by a trinomial, and we saw that every term in the first bracket has to be multiplied with every single term in the second bracket. Next, we simplified by adding up all the like terms. And when multiplying a very specific binomial and trinomial, these middle terms end up being 0, and your final answer is simply x to the power of 3 minus y to the power of 3, and in reality this is the first term of our first bracket cubed and the second term of our first bracket cubed. For these middle terms to end up being 0, we have a few requirements. Firstly, our first term in the first bracket should be squared in our second bracket, and the same goes for the second term in our first bracket. The square should be in our second bracket. And our middle term should always be formed by multiplying the two terms in our binomial, but then very important, it should have the opposite sign. In the second example, all three of those requirements once again are there. Our first term has been squared to get 4x squared. The second term has also been squared to give the plus 9y squared. And when we get the product of these two terms, it is plus 6xy, and we have that with the opposite sign. This means we can simply leave out that first step and take our first term cubed, which is 8x to the power of 3, and our second term cubed, which is plus 27y to the power of 3. Next, let's go and have a look how we will factorize doing this process backwards. Example 1. Factorize completely. Here we have two terms without any common factor, but we do have a cube in each term. When having a cube in each term, we now know that we can factorize into a binomial and a trinomial. And the binomial bracket is simply the cube root of each term, which is x plus 4y. And next we're going to use this binomial bracket to form the trinomial by firstly squaring each term, giving us x squared and 16y squared. Our middle term will be the product of these two, which will give us 4xy, but then with the opposite sign. Example B. Once again, we have two terms and every part of each term has a cube root, so we're forming a binomial and a trinomial. Our first bracket has the cube root of each term, so we'll have 2x and then minus 3y, because the cube root of any negative value is once again negative. Next, we square each of these terms to get 4x squared and plus 9y squared, and then we get the product of these two terms for our middle term, which is minus 6xy, but here we change the sign. In example C, we also have two terms, but I'm showing you this example to remind you that for two terms we've also done difference between squares, so you need to be very careful. Even though 64 has a cube root, it also has a square root, and x squared as well as y squared only have square roots. Therefore, we are going to do difference between squares factorization, forming two brackets with opposite signs, and we simply get the square root of each term in those brackets. Next, I also want to remind you to always, when factorizing, first check for a common factor. In D, we do have a common factor of 2, so we have to start by removing 2 as a common factor and then deciding how to factorize the rest of the expression. Inside our bracket, we now have two terms, and each term has a cube root. That means we are going to factorize this into a binomial and a trinomial. For our binomial bracket, we get the cube root of each term. And here I want to remind you that determining the cube root of a variable means we take the exponent and divide it by 3. That means in our bracket we will have x squared plus 2y. Next, we take each of these terms and we square them. And then we take the product of the two terms, which is 2x squared y, with the opposite sign for our middle term. Example 2. Factorize completely. Here we now have a fraction, but we still have two terms and each part still has a cube root, so we follow the same steps. To get the cube root, we start with cube root of 1, which is 1, and the cube root of 125 is 5. The cube root of x cubed is x, and the cube root of y to the power of 12, we divide the exponent by 3. Now we can square each of these terms, so that's 1 over 25 x squared plus y to the power of 8. And then we get the product of the two terms, and that is 1/5 x y to the power of 4, and we add the opposite sign. In our last example, we also have two terms, even though it looks a bit different with the brackets. So you can choose to make it look easier for yourself by substituting the bracket with a simpler variable for now. Once you've substituted, it will be very easy to see that this is the difference between two cubes. So now we can factorize this by getting the cube root of each term, then squaring each of those terms, and determining their product with the opposite sign. Next, we need to remember to substitute back and change k to x minus 2. Lastly, we just need to simplify. In our first bracket, we have x minus 2, which is minus 4. And in our second bracket, we need to square the first part, then multiply in the 2, and then simplify. And as you get used to this method, it might even get easier to do this one without substituting k.